Welcome to homework.
So we have two different situations. The first one is we have to find out the pH of 0.175 molar HY. If we given the Ka is equals to 1.5 times 10 to the left 4. The second situation is we have to find out pOH. We have 0.175 molar HX with a Ka 2.0 times 10 to the left 2. So let's start with question A. So we have HY. We're going to write the ionization equation again. So your H3O plus Y minus. And then we're going to set up ice table as usual. And then we should have a 0.175. We don't need any water. And then we should have 0 at the beginning. So we're minus 6, plus 6, and plus 6. So we have 0.175 minus x and x. And the Ka expression will be equals to x squared divided by 0.175, 1x, and then it should be equals to 1.0 times 10 to the minus 4. Okay, so in order to find out the pH, we have to find out x because it's a concentration of hydronium, and then when we take the left log, we can find out the pH. Okay, so let's set up like that. So just copy and paste our equation, and then our Ka should be 1.4 times 10 to the left 4. So 1.5 times 10 to the left 4. All right, so we have a x squared, and then we have 1.5 times 10 to the left 4 multiplied by 0.175 minus 1.54 times 10 to the left 4x. Okay, if we rearrange the equation, so we have x squared plus 1.5 times 10 to the left 4x minus our 1.5 times 10 to the left 4, which would be a Ka times 0.175. So we are going to solve for x by using the quadratic equation. When we solve for the quadratic equation, we can find the answer is equal to 5.05 times 10 to the left 3, or minus 5.19. So again, minus value over here doesn't make sense because the concentration cannot be that negative. Okay, so this will be equals to our hydronium concentration. Okay, so for pH, we are going to take a left log of our concentration. So we will 5.05 times 10 to the left 3. Take the log of it and take a negative number. And then we should be able to find that is equal to 2.30 for our pH value. And this is the answer for part A. Okay, so for part B, we want to find the pOH. So let's go to the new page. So part B, we want to find the pOH of HX. Yeah, HX, 0.175 molar. And the Ka is given to be 2.00 times 10 to the left 2. Again, we're going to show the ionization reaction. So let me just remove the pOH over here. Get a little bit distracting over there. Okay, so we have this one, HX plus water, and then we have H3O plus, and then with X minus. Again, ice stable. Initial is 0.175, and then we don't care about the water. And then we have 0 and 0. So we minus x, and then we have plus x after dissociation. So it's 0.175 minus x, where x and x. And the Ka expression will be equal to x squared, 0.175 minus x. And it is essentially equals to 2.00 times 10 to the left 2. Okay, so we want to find out the pOH. So if we can find out the pH, then we can find the pOH because pOH plus pH equals to 14. Okay, so we have to solve for the quadratic equation, but if you pay attention, this equilibrium expression is essentially same as the one we have on part A. I mean mathematically. So, and it's just the K is different. So If we go back here, we will solve for the quadratic equation. We should be able to observe that there's a pattern. So after solve for the quadratic equation will be look like a form that x squared plus ka times x minus ka times our initial concentration. So for this case, will be hx. So if you go back to here, mathematically, you can see that x squared plus our Ka times x minus the Ka times our initial concentration. So this is a faster way to set up our quadratic equation because we are just pretty much go through the same calculations. Okay, so we are going to plug in our quadratic equation to find out x. So we have Ka. Ka is 2.00 times 10 to the left 2, and then minus our initial concentration times our Ka. And then we should be able to find out that x will be equals to 0.05 or minus 0.07. Again, negative value doesn't make sense here because it cannot be negative value. So this is essentially equals to our hydronium concentration. Okay, so the pH will be going to take a negative log of our concentration, 0.05. Log of it will be equals to 1.30 or 1.3. And pOH will be equals to 14 minus pH. So we have 14 minus pH. We have 12.7 to be our pOH. And this will be the answer for part 2.